Throughout the previous few episodes, I've somewhat been putting the cart before the horse. I've been worried about mixing down these oscillating frequencies, but I haven't even figured out how to generate these frequencies in the first place. There are two signals that I need to generate, one constant and one changing. So I'm going to start with the constant one because it will probably be easier. I'm going to use a Colpitts oscillator because it works well with constant signals within the frequency range that I'm looking for, which is pretty much anywhere around 200 kilohertz or so. Now I'm a little out of my depth when it comes to oscillator design. It's super different from anything I've ever had to do yet, and seems to rely on some pretty complex stuff. I found myself with the problem that I'm able to make an oscillating signal, but it's at such an intensely low amplitude that it may as well just be direct current. I'm talking nanovolt amplitudes. A few weeks later, and I've done some more research on feedback systems and oscillator designs, and I still don't know what I'm doing, but I've chucked like a resistor here, and it seems to work. However, it looks a lot like a sawtooth wave, and I prefer it to be more sinusoidal. If I mess with the value of the resistor, then I can get some more sinusoidal inputs, but they're all at the wrong frequency. I should theoretically be getting values at about 200 kilohertz, but instead I'm only getting at about 60 or so. So I started back up from scratch and just decided to follow this YouTube video. But I still had the wrong frequency. It turned out that I had chosen very incorrect values for my capacitors and inductor because I messed up the maths. Yippee! So I reverted back to the old setup, fixed the numbers, and finally got the right oscillation frequency. Now an oscillator in isolation is pretty useless, so I need to actually connect it to the rest of the circuit. My initial idea was to replace the oscillator ground with the mixer transistor large signal bias, and then connect its output directly to the transistor. Unfortunately, this just did not work. So what I did instead was keep the oscillator connected to ground, but connect its output to the rest of the network using various resistors to get it biased at the right point. I then twiddled with the resistor values a bit to increase the amplitude of the final output, and then I had the implementation of the oscillator sorted.